Hey everyone, and welcome to Unsupervised Deep Learning Part 2, Variational Auto-Encoders and GANs. Variational auto-encoders and GANs have been two of the most interesting developments in deep learning recently. Yann LeCun, a deep learning pioneer, has said that the most important development in recent years has been adversarial training, referring to GANs. GAN stands for Generative Adversarial Network, where two neural networks essentially compete with each other. Unsupervised deep learning has become very popular lately, but what I've seen is that there is also a lot of confusion surrounding it. So no, it's not going to help you predict stocks or do fraud detection or solve CAPTCHAs. In fact, these are all supervised learning tasks. So it's important to understand the difference between supervised and unsupervised learning. What is unsupervised learning? Unsupervised learning means we're not trying to map input data to targets. We're just trying to learn the structure of that input data. Once we've learned that structure, we can do some pretty cool things. So some examples are generating poetry. We've done examples of this in the past. But poetry is a very specific thing. How about writing in general? If we can learn the structure of language, we can generate any kind of text. In fact, big companies are putting in lots of money to research how the news can be written by machines. But what if we go back to poetry and take away the words? Well, then we get art in general. By learning the structure of art, we can create more art. How about art as sound? If we learn the structure of music, we can create new music. So the possibilities are endless. Now you may have noticed that this is Unsupervised Deep Learning Part 2. So what happened to Unsupervised Deep Learning Part 1? Well, Part 1 does indeed exist, and its focus was a little bit different than this course. In particular, we looked at plain autoencoders, not the variational type, and restricted Boltzmann machines. In this first course, we still tried to learn the structure of data, but the reasons were different. We wanted to learn the structure of data in order to improve supervised training, which we demonstrated was possible. In this new course, the one you are taking right now, we want to learn the structure of data in order to produce more stuff that resembles the original data. Let's now discuss an outline of this course. The first section after this one is all about review of basic concepts. These are concepts that I'm assuming you've familiarized yourself with in the past, but that would be nice to refresh before we get into the really technical stuff. We're going to talk about sampling from probabilistic models, latent variable models, and do a quick review of neural networks and autoencoders. We'll also do a simple coding warm-up in Theano and TensorFlow, since these are the two main libraries we'll be using in this course. Next, we'll discuss the variational autoencoder. You'll see that the variational autoencoder is the combination of two big ideas, Bayesian machine learning and deep learning. This is a topic I find very interesting because it takes a problem that is formulated using the Bayesian paradigm and essentially transforms it into a deep learning problem in which you have a neural network and you train it using gradient descent. Finally, we will look at the GAN, or the Generative Adversarial Network. GANs are also really interesting because they are neural networks that integrate ideas from other fields, notably game theory. The idea is you'll have two neural networks fighting against each other, but by doing this, both of them continue to improve. Thanks for watching, and I'll see you in the next lecture.